Okay, hello. I'm Jan Holešovský. I work for Collabora, and I would like to tell you about the exciting things that we are doing with LibreOffice Online, and that is dialog tunneling. But before I get to that, I will explain you just a bit about the structure of the LibreOffice Online, so that you have the general overview, what's going on, and why we are doing this thing. So basically, the LibreOffice Online has two parts. One is the server part, which contains the daemon that is responsible for the actual communication with the clients. It spawns LibreOffice instances, so that each of the document actually has its own LibreOffice instance that is responsible for the actual typing in the document. And also, these do the rendering of the document. And also, of course, it manages the user's interactions with the document. So, passes the user events that come from the client into the LibreOffice course, so that it is possible to do something with the document. Of course, when something is happening in the LibreOffice core, the callbacks have to be routed back to the clients and do something about that. This stuff is all in C++. On the other hand, the client part is, we call it low leaflet, because it's based on Leaflet, which was originally a software for displaying maps. Which the maps, for example, OpenStreetMap maps is using that, and the entire map is split into small images. Like here, this is one of the tiles. You can see it here, and the document is composed from that. So basically, even though you are seeing a document that has the text there, it is not a text that would be in the browser. It is just a set of images that is composed together to do something that looks like text. This low leaflet communicates with the server part using WebSocket, and but the document itself is not the only thing in there. You can see also the toolbar, menu bar, status bar, and other things that are in JavaScript. But of course, it's very impractical to implement everything or re-implement everything in JavaScript. So we had to search for some right balance between what has to be in JavaScript and what has to be done and rendered by the LibreOffice core. So in the early prototypes, there were no tiles, there were nothing basically nothing in JavaScript. It was just pure invalidate everything, get me back the entire screen again, and basically the entire UI was in the browser, which was not where we want to be, just because for every action that you would like to do, you would have to render it on the server, which is very impractical. So then, we decided that the tiled approach is good because there's a code that we can reuse. There were another implementations, for example, on Android, like Mozilla Firefox on Android was using these tiles, and lots of other projects in the industry were using the tiles for actually rendering the document. So we thought it's the right thing to do. But on top of that, we started painting the overlay with the cursor and with the selections, and just because it was very impractical to send the entire bitmaps when just the cursor moved. So instead, we just started sending just the coordinates of the cursor, and started rendering that in a layer on top of that. Then next thing that turned out to be practical to render in JavaScript was comments and red lines. Just because people are used to that the comments have some nice UI, they look pretty, they can have pictures, they flow next to the cursor, when you select the text that has the command and stuff like that. So it was good to do in JavaScript. But then, what about dialogs? At first, we started implementing some of the dialogs in JavaScript. For example, the find and replace special character insert table. But like very soon, it turned out like this is no way to go. It's just too many dialogues out there. That's like very unpredictable. Takes a long time. There are hundreds of dialogues in LibreOffice, and like some of them are like extremely complex, like the cell character, cell format style, and these things. So the plan was to start tunneling the dialogues actually from LibreOffice. Let's reuse the dialogues as they are and use them in the browser. Actually, like the plan was good, but the thing turned out to be a bit more challenging than it initially looked like. But luckily, Pranav Kant did all the hard work there, or most of the hard work there, and now we have beautiful dialogues inside LibreOffice Online. You can see on the screenshot that like it has all the tabs. It has like the various custom widgets that are available in LibreOffice. For example, like seeing the line types and everything. So like because it is rendered in LibreOffice but routed to the online, you can have all the stuff. But there were lots of challenges. For example, like now, as the resulting thing, you can do it collaboratively. So you can have like two users that collaborate on one document, and both of them select the same paragraph, and both of them actually issue the paragraph settings dialog. And one of the users can like shrink the size of the paragraph, and the other can set the background to green. And when both of them like press OK, it just does the thing that you would expect. Like it shrinks the paragraph and does it green, which is awesome. But I think you can imagine that like it was not straightforward. Luckily, the LibreOffice core was very helpful here. So like the SFX framework surprisingly like did lots of good stuff for us instead of like making us problems, which was great. We initially did like all the like tunneling and messages about like what has to be done in the core and in Dialog in the SFX, but then like it turned out that we have to move it down to VCL. So now most of the stuff is done directly in VCL, which is responsible for drawing the dialogues or drawing the widgets and stuff like that, which we extended so that we have added there the callbacks that notify us about the invalidations, about the dialog creation, about site changes and stuff like that. Then for the actual for the actual rendering, we were using the screenshotting feature that was done by our friends at SIP. Then we have added the concept of a lock notifier. The lock notifier is an interface that actually allows us to do stuff in SFX2, even though like we are in the lower layer, which is the VCL. It is because like all the carrying of the views and like the collaboration between people is actually done in SFX, and in SFX we also have the mechanics of actually like notifying the right view through the LibreOfficeKit. But because like the stuff is happening in VCL, we had a way how to like skip these levels, and so this notifier is like just a way how to overtake this, and like now we are able to do stuff in VCL, but then it like the LibreOfficeKit is notified in SFX. And yeah, so we had to add a bit of API into LibreOfficeKit, which was several methods. I think they are reasonably obvious. Painting of some area in the dialog, posting some events if they are necessary so far, only closing of the window is implemented. Nothing else was necessary to be done this way. Then posting of key events, mouse events, like when the user does something in the client part, you are able to route it to the LibreOffice core. And then, of course, lots and lots of callbacks from the VCL back to the LibreOfficeKit and to the online. So stuff like created, title change, size change, invalidate, cursor was moved, cursor was done visible, and closing the dialog. So after all this was done, we thought that we have won, but not yet. There were additional challenges. So one was language support. The thing is that one document can be shared by multiple users, and one of them has the UI set in English, and the other has that actually in Czech. And what to do? Well, as you know, LibreOffice itself, when you change the language, it actually tells you, well, you cannot change it now. You have to restart LibreOffice. So we had to overtake that. Luckily, Qualon's switch to get text helped us tremendously here. Just because the infrastructure was much more prepared to actually switching. Things were cached, so or are cached. So like when you switch the language, it is not that all the files would be reloaded again. It is all like loaded once and then just used. So luckily, in most cases, it was just a matter of changing the static locale into like getting the locale again and again, like when the view was switched. Similarly, SFX module had to be adapted very similarly because again the locale there was cached, but not using static, but like as part of the object. The other challenge here and big one was modal dialogs. So the thing here is that like when you execute a dialog, like non-modal dialogs are fine, like they can hang in the view and they are all fine. But like when you have a modal dialog, you issue an execute. And like at that time, like it yields, so like all other things is still happening. So you can like from the other view issue the dialog again. That's all fine, but still like you are hanging in this execute. So like there's one execute and another execute happens on top of that. And so now what happens? Like if this user that is in the lower execute just ends the dialog. And like once his or her changes actually be visible, like it doesn't happen until like the guy that is on top of him closes the dialog as well, and the guy like who is on top of them can just disappear, and like you would never have the stuff confirmed. So it was necessary to actually convert this modal dialog to modal async. This means that like instead of this execute, you do not hang in that execute. Instead of you just trigger showing the dialog and create a callback, like what should be done when the user actually touches OK, and like LibreOffice had a mechanism for that, which was this start execute modal. But it was impractical because it was using the links, the linking mechanism that is in LibreOffice, which meant like there would be necessary to do like bigger changes to actually do that. You would have to like move the code into separate method or function, and maybe you wouldn't have some of the stuff that you need there available and stuff like that. So Michael actually changed that or introduced start execute async, which gets a lambda and actually change the modal, start execute modal into using this start execute async. So now, what is normally necessary to be done to convert a dialog from the execute to async execute is that you you create a dialog, not a scope VCL pointer, but just a normal VCL pointer, because the start execute async will then later take care of actually destroying the dialog. And instead of executing, you do not do the executing. Instead, you move the code that happens after the execute, because like there was probably here some code that was taking care of applying the changes. And you would just wrap it around this lambda, get the result according to that, do the changes. Of course, like in some cases, it's more complicated than just this, but this is the basic structure here. And usual caveat. So thanks to doing these all stuff in VCL, most of the dialogs just work out of the box. You just issue the command, command, and the dialog appears. It doesn't appear in the situation when it gets null as the parent, because like in that case it doesn't have set the loc notifier, and like in that case it is usually just enough to set the parent as the window of the view shell. If the dialog doesn't switch the languages for the user, then you have to find a place like where there's some static variable. Anything else? Happy to answer you any questions. So, thank you for listening, and thanks also to these guys who has done the work, because I've done only a very small bit of that. So, thank you so much.